if I could broadly describe what's happening in the AI space right now, there's obviously tons of hype and sky-high valuations around companies that are building foundation models. But we're pretty confident that already the foundation models that are available, both the open source ones and the proprietary ones, are kind of good enough to play a role in an arc like ours. What's much harder, at least in terms of the nitty-gritty engineering that you have to do, is getting the AI to the point where it can satisfy the enterprise requirements.
Welcome to the Conversations on Applied AI podcast, where Justin Grammons and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry, and connect with us to learn more about our organization at appliedai.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today, we're talking with Steve Hsu. Steve is a professor of theoretical physics and computational mathematics, science, and engineering at Michigan State University. He is also the founder of Superfocus.ai, which is, for lack of a better term, enterprise GPT. However, it's AIs using large language models, but with customer-defined memory to eliminate hallucination. So I'm very excited to talk about the aspects of your project today. It's an exciting new field that I'm excited to learn a lot more about. He's been the founder of countless other startups with interests and specialties in fundamental physics, research, genomics, internet security, encryption, entrepreneurship, and of course, artificial intelligence and machine learning. So thank you, Steve, for being on the podcast today.
It is great to be with you, Justin.
Awesome. Well, I gave a little bit of a, story on where you are today and what you're doing, but one of the first questions I usually like to ask people is maybe you could talk about how you got to where you are today, kind of what's been the trajectory of your career.
Well, I grew up in Ames, Iowa, which might be not that far from where you are now. Are you in Minnesota?
Yep, St. Paul.
Yeah. So grew up in the Midwest, went to college out west, was educated at Caltech and Berkeley. And if you had asked me when I was younger what I wanted to do in life, I would have said I want to be a theoretical physicist like my hero, Richard Feynman. And it was only later in life, really coinciding with the first internet bubble, that I got interested in entrepreneurship and tech startups. But that was now almost 25 years ago, so quite a while ago. So I've been kind of leading a dual life for the last 25 years or so, where I'm both a university professor and a founder of what have mainly been deep tech startups. So they're startups which are actually attempting to do something which is technically hard, but with an ultimate goal which is useful in the economy. And this latest startup is the outgrowth of a long-term interest I've had in deep learning, neural networks, and transformer architectures, but was really stimulated almost a year ago, actually now, by my co-founder, Tushar Sheth, who is a University of Michigan. He has degrees both from the engineering college and the law school, and then he served in the Obama White House on both education and innovation policy. And when he got out of government, he wanted to start a company that really would help people use a lot of these breakthroughs in AI and related areas to help people. So when he first came to me, he was mostly focused on building an AI tutor. So something that could tutor kids. And in discussing the possibilities in that area, we kind of agreed that we had to first solve what's called the hallucination problem. But the issue is basically just that the way large language models are built, and we started this company actually before ChatGPT. But I've had a long acquaintance with the OpenAI founders going back many years. So I kind of knew what was coming, and I knew we had to solve this hallucination problem if you want to do something serious like build an AI tutor. And the company at the moment is mainly focused on, as you said, enterprise GPT, so applications of large language models in the enterprise. For that, you also need to solve hallucination. So what you really could say is like our company is basically trying to build LLMs that don't hallucinate.
Mm-hmm. And well, I guess that's got to be a hard problem.
Yeah, it's a fundamental problem because the way that large language models are built is you take a very large neural net with billions, perhaps even a trillion connections, and you are training it to predict the next word given a prompt, say with N words, it's trying to predict what the N+1 word will be. And what that really is, and it's doing this by looking at huge, trillion token training data sets, which really typically tend to be scraped mostly from the internet. And what it's really being trained to do is create plausible human language. So in other words, if the next word is something that fits in patterns that it has seen before on the internet, then it's happy just to give you that next word or next series of words as the response. But you'll notice it's not trying to really nail down, exactly what is the price of that ticket from Minneapolis to New York City. It could give you a plausible answer and be perfectly happy. And so what people rapidly discovered, and we knew this already when we started the company, that the moment you're trying to do something serious, like as you edge away from human in the loop, you've got to force the LLM or the AI to be much more accurate in the information that's coming back. And so our whole company is based around a kind of software architecture which uses LLMs, but is designed in such a way as to only use the LLM for its language capability, but not to rely on knowledge encoded in the LLM. And one way we conceptualize it is we think of a customer-defined memory that we're attaching to the LLM. It's like we're doing brain surgery, and in your brain you have a language and reasoning center, which is the LLM, and we're kind of attaching to it a memory. And the memory could be just all the flight booking policies of Delta Airlines and this huge table of all of its flights and prices and seats. And that's the memory, but we force the LLM to use that memory in order to deal with user queries.
Gotcha. Yeah. And so do people load all of their corpus of text into your platform? Are you guys hosted? Are you guys like on-prem? How do people interact with your technology?
So at the moment, all the pilots we're doing right now are with the AI in the cloud.
Okay.
And generally, our partner is providing the corpus to us beforehand, typically uploading it into the cloud. And then we are building the AI so that the AI is good at responding to queries based on that corpus.
Gotcha. And you have to do kind of the hand-holding, or you have to sort of hand-hold them through the process or do some of the work, or is it kind of self-serve?
Right now, there's a certain amount of engineering that has to be done for each use case, which is specific to the particular customer and the domain that the AI will be operating in. As we get better and better, we'll start to see more use cases, which are almost identical to use cases we've already done. And in that case, it can be plug and play, where, the third travel management company comes to us with a kind of similar use case. And, oh yeah, I see your data looks a lot like the data of these other two companies already done. So yeah, we can just use our existing code base and just swap your set of, contracts and policies, et cetera, in for theirs. And the AI will work, pretty much out of the box. So we're evolving toward that, although I wouldn't say we're actually there yet.
Sure. Yeah. Again, I've started a couple different startups myself too, and you don't really know what the market really wants. You kind of build for the feature when you need the feature, right? So if you're dealing with customers right now that are okay having you sort of help them work through it, then you'll find out if they're going to need to move on to the plug and play, aspect or not, for sure.
Yeah, I mean, as a startup guy, you know that there are some engineering challenges you're definitely going to have to surmount, so you can work on those right away. Then the exact nature of the product market fit, you don't know till you actually start really doing pilots with customers, and you start to see like, oh, they don't actually care about this feature. This feature doesn't do anything for them. They're never using it, but they care a lot about this, which you didn't think about.
Totally.
Yeah. And so we're in that phase. And I think if I could broadly describe what's happening in the AI space right now, there's obviously tons of hype and sky-high valuations around companies that are building foundation models. But we're pretty confident that already the foundation models that are available, both the open source ones and the proprietary ones, are kind of good enough to play a role in an architecture like ours. what's much harder, at least in terms of the nitty gritty engineering that you have to do, is getting the AI to the point where it can satisfy the enterprise requirements. And so we're really kind of focused on nitty gritty stuff, which is, I think, a lot less glamorous. Like, I think investors are interested in the space that we're in. We had no trouble raising money, but they're not willing to give you the billion-dollar valuations from the get-go that they're willing to give some foundation model companies.
Yeah, fair enough. One of the things, as you were talking about these LLMs, it feels like you're something like ChatGPT or Bard or some of these other ones. It seems like they always want to try and give you an answer, right? It's almost like if I go on Google and I type something in, I'm always going to get a response, whether I care for it or not. It's really hard to sort of stump Google. So it feels like a lot of these LLMs, with the intent, the way that they were built, was like, you kind of have to like do a little bit of prompt engineering or sort of like, pre-tuning to get them to shut up.
Yes. No, you're exactly right. I mean, ours are, depending on which flavor you're talking about, ours are designed to actually, they're very willing to say, I don't have any relevant information in my corpus to answer your query, and therefore I can't give you an answer. Maybe you could reformulate your query. That's a perfectly acceptable response for us. In fact, we want that to happen rather than just make something up.
Yeah, for sure. And again, it probably falls under one of the enterprise requirements that you're talking about is security, or I guess fear of data leaking out into a public cloud. Another thing that your customers are talking about. Are they pretty concerned about data they're loading in?
To be honest, I don't think for a company that has a pretty good tech team, they realize that, hosting it on AWS or Google Cloud is as secure as having it, in their home environment because, it's encrypted, it's got all the protection. So I don't think it's a particularly risky thing for a company to load their data into our corpus because we follow all the best practices for security. We may eventually encounter companies that really want to do everything on-prem, but we haven't yet actually encountered anybody that really cares that much. And also, a lot of the applications that we're talking about are cases where the company's not trying to hide the data. The data is proprietary. So let me give you an example. We're in conversations with some very big call center companies, right? And so imagine you have all of the information that a person would need in order to decide whether they want to use Verizon as their calling and data plan. And there's all kinds of complicated stuff like, what's the rate? Is there a data charge? If you're on this plan, what happens? What about roaming? Does it work in Italy? They're really pretty complicated questions, but the company Verizon is not trying to hide that information from anybody. In fact, what they want from our AI is something that can answer questions about their policies and rules and products effectively and correctly. So that could be assisting the call center employee, or it could have ultimately, eventually, with no human in the loop, be actually answering questions from a user. So when you go on the Verizon site, like you're kind of hunting around trying to figure out like, oh yeah, does it work in Italy? Is there a charge? Then you could just say, can I use this plan in Italy and what will it cost me? And then the AI will just say, no, that's included in your plan. You have 100% unlimited data and roaming in Italy. So in those scenarios, security is really not the issue at all. It's not like the company, that's all public information they wish they could beam into the head of a potential customer. But so they're not trying to hide it in any way.
Fair enough. Yeah. They're trying to make it easily accessible through some sort of a human chat interface, right? More conversational.
Exactly. Yeah.
Are these companies needing to retrain their data very often? I mean, it feels like maybe an FAQ can just kind of be done and doesn't really need to be updated.
Yeah, no, this is a great point. So a lot of the pilots and things that we're involved in are cases where what will we encounter? Verizon is actually not somebody that we're working with. I just use that as an example. If you go on the Verizon site, you'll see they obviously, in order to get you to decide to buy the plan, they've got all the information is someplace on their website, as long as they keep their website up to date. All the information that you might want is pretty much there. And then they either do or don't have like an FAQ, but they might have an FAQ that they have written that's in a binder for their call center people that are trained on, right? So that information typically exists in some form. And like what we've built is an easy way to suck that into the memory of the LLM. What's interesting is that on the other hand, you could have a case where, okay, let's suppose the AI we're building is answering complicated questions about a line of cell phones that somebody might be buying, like a Motorola cell phone, or something like that. They might just have the product manual. And then you have to ask, like, can the AI just answer the questions from what's in the product manual? Or could we encourage Motorola, if we're going to work with them, to like sit down and write an FAQ for that product? And if you think about it, their people, if they're good, could write that FAQ in like a day. Or you could go to their existing call center and say, like, let's figure out what are the most common questions, and we'll write good answers to them. And then that can be in the corpus. So obviously, the more work you do in preparing the corpus for the AI, the easier it is for the AI to figure out how to answer these questions. But it's generally like something that you're talking about a relatively modest amount of human effort, and then the AI can perform very well. If you think about it, like, think of all the questions that people have ever asked, like calling the Motorola customer service line about their smartphone. Like, could there be more than like 1,000 actually different types of questions that people have asked? There's a very finite universe. For a geek like me, for a professor like me, the information content of the space is very finite. And so you're actually building an AI, and you have the luxury, because this AI might be used by millions of customers that have that cell phone. You have the luxury of doing some preparatory work and kind of covering this whole space. What's different about it is, the FAQ, if you didn't have an LLM, the FAQ could be very brittle. So if you didn't ask the question exactly the right way, keyword search wouldn't necessarily find that question in the FAQ and the answer. But because the LLMs are very good at language, I could ask effectively the same question 50 different ways, but the LLM will understand right away it is question number 246 that this person is asking about, and then I can give them the answer in language which is similar to what they used in asking the question. So that's the magic that we're taking advantage of that didn't exist like 3 years ago. But in a lot of these enterprise applications, the thing to realize is the actual information space that you're operating in is very finite. It's very limited. And you can build like 100% superhuman AIs. So the AI is better than the average call center employee, even after they've been through training and even after they've been on the job force. AI is instantaneously answering. It's figuring out which of these 1,000 questions that people ask is this guy asking me, and then giving you the perfect answer. Humans are not going to be as good as the AI for a kind of narrow application like the one I just described.
Yeah, as you were talking, I was thinking it's nice because you kind of have some guardrails to kind of stay within, right? You have this sphere of knowledge, and it's not going to really go beyond that. And I guess, where you guys are different, because I could use OpenAI today, their API, and I could fine tune my model based on all this information from call centers. But I just wanted to be clear, what you guys are doing then is that you guys are not hallucinating, right?
Great question. So often there is a conflation of what we do with fine-tuning a model. And so just to be clear, we may actually be doing fine-tuning of models ourselves to make them good at the language domain. Like, say, we're talking about features of cell phones or something like this. So we may do some fine-tuning, but that doesn't solve the problem. So what actually solves the problem is actually having an attached memory, so that once the LLM figures out what it is that you're asking about, it can actually pull information from the memory, from the corpus, and then it incorporates that information into its response. So involved in all this are multiple LLMs, so some smaller LLMs, which try to figure out what the human is after in the query, and then they pull from the data based on what it can figure out about what you're after. And then another part of our code writes that all into a prompt, but the prompt includes the answers. The prompt actually includes the answers from the memory. It's a little bit like if I ask you, like, what did you get your daughter for Christmas last year? You have to think for a second and say, like, wait, last year? Wait, was it the bunny? No, it was the pony, and some other part of your brain is like pulling information out of your memory, which is relevant to the question I just asked. And then it's showing that to the language center in your brain. And then your language center is like saying, oh, yes, Steve, you know what? We got a great deal on this pony. It's living in our backyard. It's a Shetland pony, So our architecture is essentially kind of mimicking that process. And so there's a bunch of different steps, and there are actually multiple LLMs involved in the process. There's even an error checking LLM at the end where, like, if you weren't like quite paying attention to what I said, or maybe you were drunk or something, and you just started answering, there is another part of your brain which would be like, wait, is that an appropriate response? Like, is that what Steve was asking about? Like, maybe you're about to swear because the pony like makes a big mess, like poops in the house or something. And you're like, nah, I don't want to say that actually. So then like
Filters.
it gets removed. So even have LLMs which are optimized for error correction to try to figure out like, this is not actually something you want to say at the end. So it's a kind of complicated engineering, project where you're using LLMs, but you're using a database and you're using all kinds of different things combined to get the performance that you want.
I see that. Yeah. Yeah. So totally different architecture. And like you said, if you're kind of incorporating multiple facets of it. Is this patentable? I guess you don't mind me asking. I mean, is this something that's totally unique? No one else is doing. You guys maybe are going to try and file something for it?
This is a great question. I don't know how much I should say about this, but let's just say that because we've been working on this for a long time, we were working on this prior to ChatGPT. And our engineers, did do some very interesting things. So there are some filings that we think, generally, as you know, in the software space, patents generally don't carry the day for any particular company. It's not like pharma where you can literally patent this drug and no one else is going to be able to use this drug except 15 years or whatever. So other than, Pfizer or something. Nevertheless, like we think like because we were kind of worried about this earlier than other people, we may have identified some features of the software architecture that really are crucial. And so, maybe it is possible we could get some of our claims granted by the USPTO. And then, it would be tough for other people to build something similar to us without infringing on our patent. So it is possible. But, as a startup guy, I've never had a situation where in the software space, a patent really turned out to be decisive.
Yeah, it always feels like somebody can just kind of tweak it a little bit and be like, no, mine is unique now. It doesn't follow yours.
Yeah.
Even though it does 90% of the time or 98% of the time, but they're hard to enforce.
Exactly.
And then of course, being a startup, somebody else comes in and starts using it. It's like, do you really have the firepower to take on a bigger corporation?
That's exactly right. Although having been through some acquisitions, when the acquiring company, which could be big, say it's Apple or something, they are very interested in the patent portfolio because they can prosecute that patent against other companies, right? Because they have infinite resources. So it still could play a role, but I think the real barrier, like if you just said, like if you were a VC or an investor and you were talking to me and saying, hey, what's your barrier to entry here? I would say that actually this is kind of a hard engineering problem. Like to get the system working well is not easy. And then like once you get it working well, we noticed, oh my God, this introduces a lot of latency. So now how do you beat down the latency? So it's actually a hard software engineering problem, which again, I think the market may ultimately be right, but currently the market is kind of thinking, foundation models are really hard and engineering using LLMs is easy. But I actually think from our perspective right now, it's already the case that LLMs are kind of a commodity in the sense that we could plug Claude 2 into our architecture. We can plug GPT-4. We can plug Llama 2. We have a lot of options in terms of what we can build with, including some open source models now that have commercial licenses. So to us, it's like, I'm not sure you want to pour $1 billion bet into the foundation space because I'm not sure how, some of those companies are going to make a lot of money, but a lot of them are not. Whereas this engineering stuff that we're doing right now is pretty hard and everybody's going to have to do it. So if we get there and say Walmart is having trouble and we can roll out a product where, every product on the Walmart site or on the Amazon site, you can talk to our AI about it. Like you can ask like, wait, does this take AA batteries or AAA batteries? And the AI just says, oh, AA. And it says that correctly, right? And, you can say, oh, does this contain lactose? No, this does not contain like there's going to be a day very soon where literally every SKU or UPC, every product that exists, there will be an AI that can you can just talk to the AI about the product. It will be like talking to an intelligent human that has read and memorized the product manual, the nutrition label, and has read all of the top reviews of the product that are on Amazon or on, Walmart or Costco or whatever. Mm-hmm. So that is buildable by people like us. And yes, maybe Amazon or Walmart will be able to build it themselves, or maybe they won't because there's a lot of engineering involved. And I would always bet on hungry startups over insular tech teams inside of big companies to actually do this stuff.
Yeah, for sure. Good stuff. Good stuff here. I mean, so what do you think the future looks like for large language models? What do we are going to see in the next 3 to 5 years or so?
It's very interesting because so the academics who study this, there's quite an interesting debate going on. Like some people would say you can already see some sparks of AGI in the most advanced models like GPT-4. Like it can do some very astonishing things. But on the other hand, some people would say, oh, they're kind of reaching the limit of the amount of training data that they have because they've kind of used everything. And you're not going to easily get another 10x in training data. And it was revealed recently that GPT-4 is already a mixture of experts. I don't know if you're familiar with that, but the way they for a while, it was not clear how they built GPT-4 because GPT-4 is clearly better than 3.5. And it turns out really it's basically about a dozen different or 10 different GPT 3.5s trained differently. And there's like a traffic cop that allocates your question to the version of 3.5 that actually is better to answer your question. So in a way, they've kind of reached a kind of limit. Like they might seem like 4 is better than 3.5, but not because of scale. It's actually just a mixture of 3.5s. So it is possible that with all the money being poured into building better foundation models, and I do think there are gains to be had from like tweaking the algorithm and slightly better architectures and slightly more data. So I do think you're going to see advances. So I think the models are going to be better in a few years than the models we currently deal with. But are they going to be enormously better? Not clear. Is that by itself going to solve the hallucination problem? I would say almost certainly no. So when we were starting our company, we were actually, as I said, I know some of the founders at OpenAI. And so I was having these conversations with them and I said, I really don't think you're going to solve hallucination by using X word prediction as the objective function. And they were like, oh, Steve, just wait till you see GPT-4, right? But then when GPT-4 came out, there's a big technical paper that comes with it, which tests it, including like results for hallucination testing. And what they find is that GPT-4 hallucinates less often than 3 or 3.5, but it's nowhere near like 99% or 98%. It's more like 80% or 85% accurate. And in the enterprise, you can't do that. Like if I am trying to figure out whether to buy your drill and I need to know like, how many amp hours is in the battery for this drill, electric drill. And the thing just makes up an answer because it's seen that answer. Oh, it's 4 amp hour, just make something up 15% of the time or 5% of the time. People are going to be very mad at you, right? So yeah, that threshold to cross that kind of 99% accuracy or higher that you need for the enterprise, I don't see how you can avoid architectures like ours.
Sure. And of course, the more regulated and the more that people's lives are on the line, the more the data needs to be right? I mean, it's one thing to buy the wrong drill with the wrong amperage, but it's another thing to, give the wrong dosage.
Yeah, no, absolutely. We haven't talked about medicine at all, but there are clear cases where, let's suppose I just scraped all the information from WebMD or Mayo, Mayo Clinic or some authoritative resource for, just standard questions like, oh, I have a headache, what should I do? Or I have these symptoms. Did I have a heart attack? Those are things that like a triage nurse on a helpline would be doing. But I'm pretty confident we could build an AI which is as good or better. It's like at least slightly superhuman compared to the population of nurses that staff these helplines, just based on that information. So if the human just starts giving information to the AI and the AI is using these not even rules, but just the natural language information that's on these sites, I think it would actually do a very good job of saying like, oh, I need to escalate this, or, you probably just have, this, maybe you should go get some aspirin. I actually think that's for our architecture within the realm of possibility, but I wouldn't do it. I wouldn't allow a pure LLM to do that because a pure LLM, even if you fine tuned it, is very capable of hallucinating.
Yeah, for sure. So you teach university. So do I actually here in St. Paul. I'm not a full-time faculty member. I'm an adjunct. I teach classes on machine learning and artificial intelligence around Internet of Things. So a lot of like sensors and stuff, which is always a blast. But one of the things that I always actually kind of ask people is like, what sort of advice would you have, or what advice do you give your students, I guess, that want to get into this field when they're done? Are there any courses specifically, books, conferences, full immersion?
Yeah, I would say there's sort of 2 buckets that I would talk about. One bucket is, do you want to understand actually how a neural net slash transformer architecture slash LLM works? Do you, is that important to you or not? It doesn't have to be. You don't have to be in that category. If you are in that category, then you have to learn some things like linear algebra, some things about optimization, things like this. It's kind of unavoidable that you learn this particular subset of mathematics and computer science. But then once you understand those things, you can go online, and there are very, very good lectures online where they explain to you like, oh, how does the attention mechanism work? And what's the difference between a key and query matrix? And a student, like a kid, like my son, who's, high school aged, if he knows the math, he can actually learn a lot about just from YouTube about how these amazing models actually work. So that's one bucket, which I would say, like, look, if you are decent at math, like most computer science majors can understand linear algebra. So if you are good at math and you kind of are interested in really what's under the hood, then I totally encourage you to spend some time trying to figure out, because this is the future. Like these general structures, these kinds of neural nets are going to be the way AI is done for at least the foreseeable future. And so it's worth investing some time to understand that. The other bucket is applications. So it's basically like, okay, let me just assume there is this brain in the cloud called GPT-4. There's an API. I can just submit queries to it. And at that level, you can do a lot. Just get your feet wet and write some code and just try to build some little applications. And just working with these models will give you a lot of intuition. Like even if you're not a developer, like say you're on the business side, like let's say you're 100% on the business side, and you're just trying to figure out like, how is this going to affect my sales operation? Do I need all these people? Do all these people I'm employing need to have an AI like helping them when they're on a sales call? You can't have the right intuition for how you might use this technology unless you actually spend some time with it. So I encourage everybody to do that. So I think really it's a broad, like at university, like every university should just have a class on like, either intro to AI, just the basics, or maybe some more advanced thing like, the mathematics of AI or some, you could have everything under the sun. But I would encourage everybody to take classes like that.
Yeah. And it's funny. I mean, you talk about the startup scene. It's just like, I wonder if there's an AI that can help me with this. And I feel like every day I Google something and it's like, oh yeah, there's a new startup. They're going to help you, do this now, right? And it's fascinating, I guess, to see all the applications that new companies are sort of building and trying. Now, over time, some of them aren't going to be worth their weight at all, or they're going to be problems too hard to solve, beyond just some of the basic use cases. But it's a fast-moving space right now, as you would probably agree.
It is moving super fast, and it's tough to keep track of everything. One thing I would say is that if you're like on Twitter or on YouTube and, people are constantly announcing, oh, I built this integration with OpenAI that can do this. It'll like, read your email and summarize, blah, blah, blah. There's a lot more of that stuff than there is actual production level product. Because if you actually start talking to companies and you say like, well, are you using, like, do you get any benefit other than like one of your employees occasionally using ChatGPT to look something up? So that would be direct going to OpenAI or using Copilot to write some code. Other than those two things, it's actually rare to find a company that's like, oh, there is an LLM application written by some dude that I actually get value from, and it's reliable enough that I can use it in my day-to-day business. That the number of cases like that is actually quite small. And
agreed.
You might say like, wow, super focused. You guys have 10 AI engineers and you're building stuff. They're working full-time building stuff. And you've raised millions of dollars in venture capital. Was that really necessary? Because I just read on Twitter that like so-and-so just like put that on GitHub. And I'm like, sure, yeah, go try and deploy that and see how well it works. Right. So there is a gap between perception. There is definitely tons of ideation and creativity in the space. But you always have to remember, like, there's a reason why you don't just use some home-cooked Salesforce database tool. You buy the thing from Salesforce because they actually build a professional level thing that actually works. Kids generally are not going to just whip something up that's going to satisfy the enterprise customer. So that there's a gap between what people announce on Twitter and YouTube and what is reality in the business world.
100%, for sure. I agree with that. A lot of difference between some sort of a proof of concept, right?
Exactly.
And then something that is actually in production that's being used.
Yeah. We're the ones who will tell you all the pain of the gap between bringing a POC to an enterprise-ready product. It's not small in this space, I would say.
Yeah. I appreciate the time. I got one more question for you. I mean, how do you see this affecting the sort of the future of work? Whether it be your tool or AI in general, like, what you talk about your son, right? What's it going to be like for him when he gets out into the workforce? Do you think, how is AI going to affect that?
I think that it's hard to predict how it's going to affect.
Because there's some jobs that haven't even existed or haven't even been invented yet, right? I guess.
What I will say is that I was just actually tweeting about this morning, so it's kind of funny. There are already some studies. There's a Stanford business school professor who did a study of call center workers. So I think they looked at 5,000 call center workers, some of which were given access to ChatGPT to help them. And these were not specialized AIs like the ones we built. These are just general ChatGPT. And they found a roughly 15% efficiency gain for the employees that had this tool available to them. So if you think about that, it's not trivial. That's like 1/6 of somebody's salary, right, is the value they were getting from this tool in this academic study. And so that's got to put downward pressure on the demand for labor in those segments. And we see tons of interest from call centers and customer service companies in wanting to talk to us about like an AI that will help them. So I see a lot of jobs where there's going to be huge impact, where a few years from now, literally everyone working in that job category will be doing it partnered with an AI. Some of them will be actually what they were doing today in 2023 is no longer done by a human because it is almost human out of the loop. It's being done by the AI. So I think there will be some categories like that, although the minority. But in the short term, definitely, even just in a few years, a lot of people are going to be working partnered with an AI to improve their efficiency. I can see many, many cases of stuff like that.
Yeah, and it's a big debate. I was just on a podcast earlier today where, it's kind of like job loss versus job augmentation. I realize there are definitely going to be some job, losses. There's people, you just don't need as many people when the people you have are becoming 15% more efficient.
15 was in that study, which they did, right? They did that study, maybe the paper came out in early, like spring of 2023, so just a few months ago. But they were using very early tools. And I would guess with what we can build, I would guess not 15%, but maybe 30% more. And then at that point, it's like, well, that is definitely macroscopically affecting the number of people you need in these jobs. Like, oh, you need a third less people in your call center than you needed before. You'll notice that. Like one of our investors in Superfocus is a fund based in the Philippines, and they have very tight connections to the call center industry. And the government there is already very worried about this because the call center work is 8% of their GDP in the Philippines. And so they're scared like crazy trying to figure out how are we going to help all of our domestic companies adapt to possibly reduce demand for human capital because of AI. And so they're taking it very seriously.
Yeah. Yeah. Again, it's going to remain to be seen. Obviously, there's some people that are going to have to be let go. And there's others that are going to be like, well, how can we use you in a better, more humanistic way, right? Better the things that humans are good at.
The joke that I've heard from the Philippines side of this is like, wow, I guess the case for UBI is like, people are just going to see their handwriting on the wall pretty soon that like, wow, UBI is kind of like, if you want to have a humane society, you better have some UBI because there are going to be some humans that, ultimately their skill set is surpassed by what machines can do more cheaply. And then like, well, if you want to be humane, like all that extra productivity we got in the economy, we should give some of that to these people so that they can have nice lives, even if they've been made a little bit obsolescent by the machines.
Yeah, for sure. That was Andrew Yang, right? What's his book? He had a pretty good book.
Yeah, I forgot the name, but the funny thing is like a few years ago, there was a huge amount of discussion of UBI, and then it kind of went away. I guess I'm back thinking of the last election, 2020. And then it kind of went away for a while, but what we're seeing now, people like specifically our company and companies like us that are like, oh, you see this little super specialized AI we've built for you and it works better than a human for doing this class of things that you need done. At that point, the light bulb goes off again and they're like, wait a minute, we're going to need UBI because there are a lot of people that are just not going to be able to, you're better off with the AI than with the person. And I do think that's going to be something the societies are going to wrestle with.
For sure. Yeah. Hey, the book is The War on Normal People. Actually, it's really good. It talks about truck drivers and what happens once all these. So yeah, it sets up the first couple of chapters are a little bit.
The funny thing is a robot still humans are very nimble, and the LLM breakthrough didn't suddenly make the robot extremely good at wielding a soldering iron or something like that.
Yeah, the manual.
For those processes in the factories, you have to just set things up in a very rigid way so the robot can do it and be very good at it. But these LLMs are so flexible, things that have to do with processing with human language, communicating with humans, figuring out what the human wants. The LLMs are extremely good and flexible at that. So that's going to be a place where I think a lot of people, in a way, kind of made redundant by LLM technology.
Yeah, cool. Well, Steve, I appreciate your time. How do people get a hold of you? Is it good to find you on Twitter, LinkedIn? What's your handle?
If you want to pilot one of our AIs, if you run Delta Airlines, you can reach me. Let's see, what's the right way to do this? You can DM me on Twitter. You can find me on LinkedIn, all of those places.
Yeah, we do a full transcription of everything we talked about here, and we also have liner notes in there as well. So I will make sure to have links to Superfocus and links to you on LinkedIn and Twitter and all that sort of stuff. So make sure to get that. So thanks again, Steve. I appreciate it. This was a great conversation. And your product sounds super interesting. So nothing but the best of luck. I'm sure as you guys are working more and more in this space, it feels like something that, like you said, specifically enterprises are going to need this product. So best of luck.
Yes, thank you very much. It's been a pleasure.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at appliedai.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at appliedai.mn if you are interested in participating in a future episode. Thank you for listening.